Now let us discuss another numerical problem from engineering mechanics, Tata McGraw-Hill 5th edition by S. Timosing Cordia Chiang, J.V. Rao, Sukumar Pati. So let me straightway go to the statement of the problem. It is from problem set 2.1 and solution to 2.16. 2.16 of problem set 2.1. Now the statement of the problem is like this. If the resultant of two forces, look at this figure, there are two forces, one to this side 1000 Newton, making an angle of 15 degree with this dotted line which is horizontal. This is another force P, we don't know. This angle beta also we don't know. And this dotted line is vertically downward. If the resultant of two forces exerted on the body at A, these two forces, this 1000 Newton and this P Newton force are acting at point A, and this is figure J in your book, is to be vertical. The resultant of this force and this force is to be vertical. Then determine the value of P and the angle beta when the resultant of the system shown is vertically downward. When the resultant is vertically downward, find out the value of P and beta. So, let this 1000 Newton force be represented as Q, which is represented by the side AB in the following figure. In the figure below, resultant of 1000 Newton, that is which I took it as Q, and P is to be vertical, that is given in the question. So the same diagram I have redrawn it here. This point A is same thing as this point A. This 1000 Newton is same thing as this force from A to B, and this P Newton is from A to D. Right, let me write it P here. From here to here is Q. Right, that is 1000 Newton. Now let us, Q is equal to AB is equal to 1000 Newton. P is equal to your AD. So if you take AB as one force and AD as one force, and if you construct a parallelogram, the diagonal passing through this point, that is AC, will be the resultant. So your AC is the resultant of a P and Q. AC is the resultant of P and Q. Oh, 1 second. Oh, something. Now, what I have done is, B is perpendicular drawn on AC. Look at this, BE is perpendicular drawn on AC. So this dotted line and this dotted line, they are parallel. So therefore angle ABE is 15 degree. ABE, this angle is 15 degree. Why? This dotted line and this dotted line are two parallel lines. This is the transversal, so this is given as 15. Therefore, this will be 15 because alternate. If this is theta, then this is theta. If this is 15, this is also 15. Now, again, AD is parallel to BC. Now, AD is parallel to BC because this ABCDA is a parallelogram and AC is the transversal. Therefore, since it is given angle CAD is equal to beta, this is given, therefore angle ACB, this is also beta. This is parallel to this. This is the transversal. If this is beta, therefore this will also be beta, alternate angle. Therefore angle CAD is also ACB is beta because CAD is given as beta. Now let us move on to the next page of the solution part. Now is interesting. Now look at the triangle BEC. Look at the triangle BEC. This I just proved as beta. This is 90 degree here. So this much angle will be 90 minus beta in the triangle BEC, because the sum of the three angles has to be 180 degree. Now if you look at the triangle ABE, this is 90, this is 15, I have just proved. So I am left with one more angle, this angle. So sum of the three angles, this plus this is 180. This is 90, this is 15. So this much will be 75. Angle BAE will be 75. So in triangle BEC, CBE is 90 minus beta, just I explained you. And your ACB will be, therefore, your angle ABC. Look at this part. Angle ABC. Angle ABC. That is this angle. This is 90 minus beta, this is 15. So 90 minus beta plus 15 will be angle ABC. So that is equal to 90 plus 15, 105 minus beta is your angle ABC. Now we know the sine rule. Now apply sine rule to the triangle ABC. That is Q over sine beta. AB is represented by the force Q, and the angle in front of the side AB is this angle beta. So Q over sine beta, that is what I have written here, will be equal to P over sine 75. How? Now this side AD represents P. The length of AD is equal to the length of BC. So then BC is also equal to P. And the angle in front of the side BC in the triangle ABC, that is this angle, which I just proved as 75. So P over sine 75. Now we are left with one more side, the resultant. That is from A to C, the resultant. And the angle in front of this side in the triangle ABC is this angle, 90 minus beta plus 15. So is equal to R over sine 105 minus beta. Now let us consider these two things only. That is Q over sine beta is equal to P over sine 75. So if you cross multiply, you get P is equal to Q sine 75 over sine beta. Q is given as 1000. So 1000 sine 75 by sine beta. We don't know beta yet. Now we'll prove it to be 15 degree. Now look at this is a fraction. If beta is equal to 0 degree, sine 0 is 0. Something by 0 will be infinite. So P will be infinite if beta is equal to 0. Now, and the second part of the argument is if beta is equal to 90 degree, if beta is 90 degree, sine 90 is 1. So 1000 into sine 75 by 1 is 1000 sine 75. That is equal to 965.925 Newton if you just put it in a scientific calculator. So what is the conclusion? So beta is definitely not 0. If beta becomes 0, your P becomes infinite, which is not possible. Now, therefore, beta is above 0 degree and less than equal to 90 degree for P to be maximum. For P to be maximum. Now only last place for P to be maximum. So if P and Q are rectangular components of R, implies beta is equal to 15 degree, that is 90 minus 75 is 15. I will explain you how. If P and Q are rectangular, how beta will be 15 degree. Look, this is your Q, this is your P. If they are rectangular, and this is 15, and this line AC, the resultant, is vertically downward, means this line is perpendicular to this dotted line, means the angle from here to here is 90, and since this is perpendicular to this, because P and Q are rectangular, then the angle from here to here is again 90. So out of these two 90, which angle is common? This angle is common. Look at this way. This is 90. Then this is 90. So out of these two 90, this angle is common. So whatever left, so if this is 15 degree, so therefore this will be 15 degree. Means if you take out, here is 90, if you take out something from here, here is 90, if you take out the same thing from here, let's say x, so whatever will be left will be equal. So from this 90, 75 is taken out, left with 15. From this 90, 75 is taken out, so I am left with 15. And this was your beta, so beta is equal to your 15. So for this, the P will be maximum for a given value of Q and a given direction of R, which is vertically downward. Therefore P maximum, this I just explained from the sine rule, P was Q sine 75 over sine beta. Now put the value of beta as 15 degree and put this in a scientific calculator, 1000 sine 75 by sine 15. This comes out to be 3732 Newton. Thank you.